It is evaluating the cost with the possible path and expanding the path with the lowest cost. As an example of best first search algorithm, the below graph, suppose we have to find the path from A to G. This algorithm can be very efficient to find a solution quickly even in larger search spaces. All the values here, the 6 is the smallest value or lowest value of all the values we found out. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us continue our discussion with the chapter Problem Solving by Searching. So, in this session, let us discuss about different types of algorithms, informed search algorithms, greedy best first search algorithm, and A-star search. So these are the topics to be covered in this session. Now let us start with the first one, greedy best first search algorithm. Now what is the definition of this? So it is an AI search, artificial intelligence search algorithm that attempts to find the most promising path from the given starting point to the goal node. So this algorithm is always promises to give the best path to reach the goal. It prioritizes the path that appears to be the most promising, regardless of whether or not they are actually the shortest path. So, regardless of shortest path is going to promise the best path to reach the goal. It works by evaluating the cost of each possible path and expanding the path within the lower cost. So this process repeated until the goal is reached. How is going to work or how algorithm functions? So it's going to evaluating the cost of each possible path. It's going to calculate the cost of each path from one node to another node and also expanding the path within the lowest cost. So by considering the lowest cost, it's going to extend or expand the path in towards reaching the goal. So this is how it works. So this is the definition of greedy best first search algorithm. Now let us see the example here. So this is the starting node A and these are different nodes D, F, C, E, B, H and G. And if you look at the numbers here, all these are the heuristic value of particular node here, and this is G's goal node, and always the value for goal node is 0. So by considering this example, let us see how it is going to function. Now in this, let us see how it is going to work. So it is evaluating the cost with the possible path and expanding the path with the lowest cost. It uses the heuristic function to determine the path with the most promising path. So here it also includes the heuristic function. So what is it? So it is nothing but into account the cost of the current path and the estimated cost of the remaining path. So the heuristic function is the one we are going to find out with the help of function, and is the function is going to consider cost of the current path and estimated cost of the remaining path. Then we get the heuristic value. The cost of the current path is lower than the estimated cost of the remaining path, then the current path is chosen. So here if the cost of the current path is lower than the estimated cost, so this heuristic function we are going to consider the cost of the path and estimated cost of the path. So if the current path is, it has a lower value, the cost is less than the estimated value, then it's going to choose the current path. So this process repeated until the goal is searched. So this is how this algorithm works. Let us see the example here. As we are seeing the example, so let us consider this example. Now here, if you look at the value, there is a heuristic value of each node here. So first this is a starting node. From here it has the two possible nodes and it can take any of the possible nodes. or any of the two possible paths. One is A to D or next one is A to B. But here the value of this D is 35 and this is 32. And again the C is 25. So there are three possible paths. It can take A to C, A to B and A to D. So out of these three heuristic value, the 25 is the small. It is the lowest cost value. So it is going to take this path. So from A to C is the first path. So now let us see the explanation of this. If you are starting from A there are direct paths to node. That is to B, it is a one path with the value 32, and A to C with the heuristic value 25, and A to D with the value 35. Out of 35, 32 and 25, 25 is the least value, the lowest value. It takes the path A to C. Next, as per the first search algorithm, choose the path with the lowest heuristic value. Accordingly, it takes this path. So it's going to move from node A to C. This is the first movement. Now next one is from C. Now let us see next path here. From C, there are two possible paths for this. There is C to F with the heuristic value 17, and C to E, the heuristic value is 19. So out of 17 and 19, 17 is the lowest value. It takes this path from C to F. See, from here, from C, we have direct path to C to F with the value 17 and C to E with the value 19. So it takes the path C to F. The next path is, so from F, we have direct path to node G with the heuristic value 0, and always the goal node, the heuristic value of a goal node will be 0. And so we'll go from F to G. This is the next step. Next one is, as an example of best first search algorithm, the below graph, suppose we have to find the path from A to G. Finally, is going to reach the goal by taking the path from A to C, C to F and F to G. So this is how this algorithm functions. Now let us see once again the diagram here. See, from C to F. After F, here it can take, there are two possible paths. One is G, direct path from F to G with the heuristic value 0, or it can take D to F to D, that is with 35. So 35 and 0, 0 is the lowest value. It takes this route or this path from F to G directly. So finally it reaches the goal. So to reach the goal, it start from A, the path would be A to C, C to F and F to G. So by considering the lowest heuristic value of each and every node in the graph. So this is how this works. Now let us see the advantages of greedy best first algorithm. So one is simple and easy to implement, one of the application. Second one is fast and efficient. Next one is low memory requirement. These are the advantages. Next one is flexible. It is flexible, adapted to different types of problems and can be easily extended to more complex problem. This is a flexibility. So the same algorithm can be used for different types of applications. And efficiency. So if the heuristic function used in this algorithm is good to estimate how close the node is to the solution. This algorithm can be very efficient to find a solution quickly even in larger search spaces. So it is more efficient even in larger spaces or if there are more number of nodes in a graph. Now let's see the drawbacks of this. Here one is inaccurate results. Actually it is a optimal solution or the best solution, but it cannot guarantee the results, accurate results. So it is local optima, means it can get stuck in a local optima, means the path chosen may not be the best possible path. So actually this algorithm is going to promises the best optimal path, but that may not be the right path. Then heuristic function. So actually this requires the heuristic function in order to work with. So if at all it is going to execute this, we should know the heuristic value or heuristic function. Then lack of completeness. So here it may not always find a solution if one is exist. Here it is not a completing algorithm, meaning it may not always find a solution if one is exist. This can happen if the algorithm gets stuck in a cycle or if the search space is too much complex. So if the search space is too large, is in a more complex problem or examples, it may not complete the algorithm. So that is lack of completeness. In the next slide, we will see applications of greedy best first search algorithm. One is the path finding. So here it is used to find the shortest path between the 2 points in a graph. It is used in many applications such as video games, robotics, and even navigation system. That is a path finding. Next one is machine learning. Machine learning, here it can be used to machine learning algorithm to find the most promising path through the search space. Next one is optimization. What is optimization? Optimize the parameters of a system in order to achieve the desired result. Next one is game AI. This algorithm can be used in gaming also, used in games. AI to evaluate the potential moves and choose the best one. So these are all the different applications of greedy best first search algorithm. And in the next slide, we see some other applications. One is navigation. It is used to find the shortest path between the two locations. And NLP, natural language processing, can be used in NLP tasks such as language translation or speech recognition to generate the most likely sequence of words. This is another advantage of this greedy best first search algorithm. Next, image processing. These are all the few advantages of greedy best first search algorithm. Now let us move on to next one, that is A star search algorithm. Another type of algorithm is A star search algorithm. So let us see the definition of this. So here, one of the best and popular technique used in path finding and graph traversals. So what is the meaning of traversal? Means it is the best algorithm. It is really smart algorithm which separates it from the other conventional algorithms. It is quite different from the whatever we have learned so far or with other conventional algorithm. And many games and web-based maps, these are the applications. Games and web-based maps use this algorithm to find the shortest path very efficiently. It may be approximate. So this is the definition of algorithm. It is the best algorithm and it is quite different from other algorithms. The examples may be in many games as well as web-based applications. Now let us look at the example here. So this is the graph with S is the node here, A, B, C, D and G here. So if you look into that, so here these are the state, these are node as well as these are the function or the value of S, this is 5 and this A is 3, this is 4 and C is 2 and D is 6 and G is 0. Always the goal node value supposed to be 0. By looking at this function and this table, so this is function is important. So we have to find out the best optimal path in reaching the goal here. Now let us look at the example now, how it is going to function. Now if you consider the S, the starting node, and from here S to A, this is the node A and there are two possible values, S to A and S to G directly. But here this is the cost of the path from S to A, the cost value is 1 and S to G, this is 10. We have to consider this as well as this and also the value for A node here. The value of A is 3. If we want to reach from S to A, we have to consider the path cost as well as the heuristic function value, that is 3. And again, you have to consider this path as well as the value of the function heuristic value of the node G. So by comparing these two, whichever has got lowest value, it has to go, we have to follow that particular path. Now let us have an example now. See in this one, look at this value is 1 and this value is 10. And the value of A is 3 and value of J is 0. Look at this table. What is the step number 1? So 1 is the path, yes, directly it goes to A. We have to consider, we have to find out this is G of n is nothing but the cost path, that is 1, as well as this is heuristic function value, this is 3. This is, we have seen in the table, this is the function table. So the value of A is 3 and value of J is 0, 1 and 10. By considering this, note on the value, it is 1 plus 3 equal to 4 and this is 10 plus 0 equal to 10. So this is out of these two, 4 is the lowest. So we have to select the lowest value and this we have to keep it on hold. This value is 10, you have to keep it on hold. Now the A, from A, we have to take then another route here. One is A to B is one path and A to C is another path. So if you consider the value here, A to B, the value, the cost path is 2 and this cost path is 1. And the heuristic function value of B, it is 4 here and C, it is 2. By adding these two, we can find out the lowest value. So if in that case, look at the second step from A. After moving from S to A, from A to B and A to C, there are two possible paths. By looking at the value, so finally the function value is 3 plus 4 is 7 here and it is 2 plus 2, 4. Out of these two, 4 is the lowest value. We have to select this path and this value path has to be hold. In that way, it has to move from A to C. In the example, from here, from A to C, this is the best path, optimal path between B and C. So this is the one. Now the node is here. From here, C. Again, you have to take C, the two possible values, that is C to D and C to G. But C to D, it is value is cost value is 3 and this cost value is 4 and the heuristic function value of D, this is 6 and this is for 0. Look at the table here. So here it can take yes, after C it can go to D, there is a one path. The value is 5 plus 6, it is 11, this is 1. Next one is another path is after C, it can take to G, directly it goes to G. Here 6 plus 0, that is 6. So this is the lowest value. And this is 11, we have to keep it on hold here. So this is the path. So it's going to take from C to G directly with this path by reaching the goal node here. Now from C to G. Now if you look at the table here, now if you consider the value is, finally we got the final path as S, A, C, G. And here the value we got is 6. My next step is we have to compare this value with other values which were on hold here. Now this 6 is less than 11, 1 point, and again it is 6 is less than 7. So again one more hold value is 10. So 6 is less than 10. All the values here, the 6 is the smallest value or lowest value of all the values we found out. This is the optimal path with the value 6. So final path will be S, A, C, G. This is from here S, A, C, G. This is the optimal path to reach the goal node from the starting node. Yes. So this is how the A star search algorithm works. Dear students, so far we have discussed about two algorithms. Now let us continue our discussion in my next session. Thank you very much.